Hello everyone, I am Manav Thapar and today we'll be studying a very exciting topic, surface area and volume, where we'll be understanding 3D objects and their measurements. We'll break this topic down into very simple and fun way. So let's get started. So firstly, we need to understand what are 3D and 2D shapes. In geometry, a three-dimensional 3D shape is an object that has length, breadth, and height. So we all know 3D shapes have three dimensionals, length, breadth, and height. Unlike 2D shapes, which only have area, 3D shapes occupy space and have surfaces, edges, and vertices. So 2D shapes, they only have length and breadth. That is why they're known as two-dimensional and they only have area. A few examples of 3D shapes which we'll be studying ahead will be cubes, cuboid, cylinders, cone, spheres, and hemispheres. Now, before we jump to the 3D shapes, we need to understand the meaning of surface area and volume. So, the surface area of a 3D solid is the sum of the areas of all its faces or curved surfaces. It is measured in square units like centimeter square, meter square, etc. There are two types of surface area that we're going to study. Firstly is the lateral surface area or curved surface area. It refers to the area of only the side surfaces of a solid, excluding the top and bottom faces. For solids with curved surfaces like cylinders, cones, it's called curved surface area. So lateral surface area or the curved surface area is the surface of the solid, surface area of the solid, which excludes the top and the bottom. So that will be the lateral surface area. And if the solid is curved, it is known as the curved surface area. Next we have is the total surface area. In short, we write it as TSA. As the name suggests, it is the sum of all the outer surfaces. That will be the total surface area of a solid. Then we have is volume. The volume of a 3D shape is the amount of space enclosed within it. And it is measured in cubic units like centimeter cube, meter cube, etc. Volume, as we know, is also the capacity of a 3D solid. So as the basics of this chapter is clear, we can start with the discussion of our first solid, which is the cube. So a cube is a solid bounded by 6 equal square faces. All edges are of equal length. So a cube is a solid which has 6 faces and all of them are squares. So I'll just mark which is the face, like this one. This thing will be called a face. This whole thing will be called the face of the cube. So like this, it has 6 faces. A cube has 12 edges. Edges are nothing but these lines. So this line would be called an edge of the cube. So there are 12 edges. It has 8 vertices. So the points where the vertices meet, where the edges meet, are called the vertices. So this point would be the vertex. This point would be the vertex. So there are total 8 vertex in a cube. Next, we have a list of formulas for a cube. First one is the lateral surface area, which is 4 times a squared. Now, as we had discussed earlier, lateral surface area is the area of the surface area of the solid, which excludes the top and the bottom. Now, a cube has all its faces as squares. We know that the area of a square is a square. If the side is a, it will be a square. Now, if we are excluding the top and the bottom, in a cube we are left with 4 surfaces. So the lateral surface area would be 4 multiplied by a square, which is 4a squared. The total surface area would be 6a square. Reason is because a cube has 6 surfaces, 6 square surfaces, and area of each square is a square. So total surface area becomes 6 into a square. The formula for volume is a cube, and the length of the diagonal is root 3 times a. Now here the diagonal is a line joining the opposite vertices. Okay, I'll make this with a line. Like if you join this vertex and this vertex here. This would be a diagonal. Similarly, if you join this vertex and this vertex here, this would also be called the diagonal. So in a cube, we can have a total of 4 diagonals. I hope this is clear. Next, let us see how to apply the formulas that we have just learned using a few simple questions. So the first question we have is a cube has an edge of 7 centimeter. Find its total surface area and volume. So in the first question, we have been given the edge of the cube is 7. So the value of A is 7 centimeter. Here, first thing we need to find its total surface area. So in short, we can write TSA, total surface area, is equal to 6A squared. This is the formula for TSA of a cube. So we get 6 multiplied by the value of A is 7. So 6 into 7 square. This will be 6 into 49. And 6 multiplied by 49 will give us 294. And the units, as we have studied, for surface area is centimeter squared. So the total surface area of the cube is 294 centimeters square. Next, we need to find its volume. Now, formula for volume is A cube. Again, we'll put in the values. So this will be 7 cube, and 7 cube is 343. 343. And the units, as we have studied, for volume is cubic units. So this will be centimeter cube. So this is the answer, centimeter cube. So this is the answer for volume, 343 centimeter cube, and 294 centimeter square is the value for the total surface area. Yes, I hope everyone understood this. Now, in the next question, we have been given the total surface area of the cube is 150 centimeters square. We need to find the length of its edge and its volume. All right, let's try the second one. So in the second question, we have been given the TSA, total surface area, is equal to 150. So here we'll apply the formula. The formula for total surface area is 6A square. 6A square is 150. So A squared would be 150 divided by 6. Now 150 divided by, we'll move to the next page. So we have A square is, I'll write it down again, 150 divided by 6. And when we simplify, this will come to around 25. So A squared is 25, and therefore A, that is the length of the edge, would be square root of 25, and this will give us 5 centimeter. So this is the answer for the first part. The length of the edge is 5 centimeter. Next, we need to find out its volume. So again, we know that the formula of volume of cube is A cube. So we get 5 cube, and we know that 5 cube is 125, and the units would be centimeter cube. So this is the answer. I hope this is clear to everyone. Next, we'll discuss the second solid, which is the cuboid. A cuboid is a solid bounded by 6 rectangular faces. Opposite faces are equal. Now, a cuboid is very much similar to a cube. The only difference is in a cuboid, all the faces are rectangular. So it has very much similar property to that of cube. Like it has equal number of faces, it has equal number of edges, and it has equal number of vertices. So let's discuss the faces. So here I'll firstly mark what is the face of the cuboid. So this one, this would be a face of the cuboid. So there are 6 rectangular faces. Next, when we talk about edges, the horizontal edges, the 4 horizontal edges which I'm marking right now here, they are called the length of the cuboid. I have marked 4 horizontal edges. They are called the length of the cuboid. And next, the other horizontal edge which I'm marking right now are called the breadth of the cuboid. And the vertical edges which I'm marking now, are called the height of the cuboid. So here the edges which I have marked with the same color have equal measurement. Very, very, very important. So the horizontal edges will have equal measurement. The vertical edges will have equal measurement. And these are called the length, breadth, and height respectively. So with this, we have the first formula, that is the lateral surface area of a cuboid. The formula is 2 times h bracket L plus B, that is 2 times the height plus length plus into length plus breadth. Now, as we have studied, lateral surface area is the area which excludes the top and the bottom. So basically we need to add 4 rectangular surfaces. So if we talk about the first rectangle surface which I am marking, the one at the front. Now the one at the front and the one at the back, they will have equal areas, and this would be length times the height, L into h. Similarly, we also need the surfaces which are on the sides, that is this surface, the one on the right and the one on the left, as they have equal areas. So firstly I will write that would be equal to breadth times the height. And since we have 2 of each, we will multiply this whole thing by 2. And this is how we get the formula of the lateral surface area. We just have to take the h common. So when we take h common, we get 2 times h bracket L plus B. So this is the formula for the lateral surface area of cuboid. Next we have is the total surface area. Now here in this formula, lateral surface area, we just add the top and the bottom. Now the top rectangle would be L times B. So if in this formula we add, I'll just show it here. If in this formula, if we add 2 times BL, since the top and the bottom is breadth into length, to the formula of lateral surface area, we get the formula for total surface area. All right. Next we have is the volume. The volume of the cuboid is length into breadth into height, LBH. And lastly we have is the diagonal of the cuboid. The formula for diagonal is square root of L square plus H square plus B square. Now if we talk about the diagonal, it's the same as we have discussed in cube. Diagonal would be the line joining the opposite vertex. So if I join this particular vertex here to this particular vertex, this line which I get would be called the diagonal of the cuboid. Here also we have 4 diagonals. I hope this is clear to everyone.